In this section, you're going to learn about the difference between the interior of the Earth and the interior of Mars. You can disregard the section in the bottom right about the moon. The first thing to notice on this diagram, I don't even have a cursor. All right, the first thing to notice on this picture is that both Earth and Mars have a crust. In the picture, it says continental crust for the Earth, or oceanic crust, and for Mars it says basaltic crust. But all you have to know is that these are crusts. It's the outside rocky, relatively cool part of the planet that you could stand on. The Earth is obviously much larger than Mars, but the important difference is in the dark brown part of the Earth, the fluid outer core. That fluid outer core is important because it generates a magnetic field. Earth's magnetic field is very much like an invisible force field that deflects what would be dangerous particles from the sun and quite often from outer space. If that magnetic field were to disappear, that wouldn't necessarily sterilize the surface of the Earth, but incidences of cancer and mutation would be significantly higher than they are right now, and ecosystems on the surface of the Earth would change considerably. Mars does not have this fluid outer core. Mars does not have a magnetic field, which means the surface of the planet is exposed to very high levels of radiation. This is something that future astronauts or people living on Mars will have to deal with, probably by living underground in something called lava tubes. We believe these exist on Mars. We know they exist on the Earth. They would provide adequate shelter, but nonetheless, the psychological consequences of living underground haven't really been tested before, except perhaps on things like submarines. But the surface is off limits for long-term exposure to future Martians.